Number 8, we want to evaluate b squared minus 4ac. So this part is the part that's under the square root when we do the quadratic formula. It's also called the discriminant. Kind of lets us know how many solutions we'll have. So this time b is 9, so we'll do 9 squared minus 4 times a, which is negative 7, times c, which is negative 6. So this will give us 81, 4 and 7 give us 28, positive times a negative, so it'll be negative. And then 6 times 28. So I'm going to do like a little mental math. 28 is the same as 30 minus 2. And it's easier to multiply 30. So 6 times 30 gives me 180. And 6 times 2, subtract 12, so that gives me 168. So this should be a negative 168. And then when we subtract 81 from 168, that gives me a negative 87. So let's just double check that we should get a negative 87. We've done everything correct, so we'll say 9 squared minus 4 times negative 7 times negative 6. We get negative 87, so it looks good. Oh, I didn't put anything in. Negative 87. Alright. Alright, so number 9, we want to find the x and y intercept. So this is just kind of cycling through, making sure we remember some of those things we've learned in the past, because we'll continue to need them. So we have f of x is equal to 9x plus 5. Okay, so this is the equation of a line in slope-intercept form. This is the slope, this is the y-intercept, so I don't have to do any work. If you put a 0 for x, that term goes away. Your y-intercept is given for you. All right, so our y-intercept is 0, 5. When we want to find the x-intercept, we make y equals 0. Well, we don't see y. This f of x is represented by y. So I'm going to say 0 equals 9x plus 5. We're going to solve for x. So we would subtract 5. So we have negative 5 equals 9x. And then you divide by 9. And so we get x equals negative 5/9 as an ordered pair. Negative 5 over 9, comma 0. So x-intercept negative 5/9, 0. And then the y-intercept 0, 5. All right, number 10, our last problem, wants us to determine the domain and the range of the function. So because this graph runs off the page, that means it's going to continue to go left. Domain is left and right. So it's going to continue to go left forever. So my leftmost point is going to be negative infinity. Okay. And the same thing, this graph is going downward, but I'm focusing on left and right. Runs off the page, so that means it's going to continue to go right to all the positive values. So our upper end of our domain is infinity. So this graph goes from negative infinity to positive infinity for my domain. And then our range is going to be top to bottom, the y values. So we always go to the lowest point first. So as we can see, this graph is going downward, and it looks like it runs off the page. So it's going to continue to go downward forever and ever and ever. So that means my lower end of my range is going to be negative infinity, because this graph is going to continue to go down. Now, how high does it go up to the top? Okay, so it goes to a height of 3, and it stops and turns around. So the highest point is 3, and since we actually reached 3, I want to put that in a square bracket. So I'm going to put a 3 here, and I'm going to change this closure to a bracket. Okay. So I want to open parenthesis negative infinity up to 3 with a bracket.